Stoichiometry. Fun stuff. Let's do one more. Make sure we've got this process down. Stoichiometry is the relationship between relative quantities of substances taking part in a chemical reaction. Moles react with moles based on the coefficients of the balanced chemical reaction. And so we can't measure moles in the lab, we measure grams. And so we've got this process that we use of grams to moles to moles to grams. The first step of going grams to moles, we use molar mass. The second step, we're going to use some sort of stoichiometric ratio that we get from the balanced chemical equation. And the last step of going from moles to grams, we're going to use the molar mass that we calculate using the periodic table. So let's look at this equation. CH4, which is methane, plus molecular oxygen reacts to make carbon dioxide and water. This is a type of reaction that we could call a combustion reaction. Methane is natural gas. And so if you're cooking on your stove in your kitchen, this is what you're using. And so we need a balanced chemical equation. And to balance it, we need a 2 in front of the molecular oxygen on the reactant side and a 2 in front of the water on the product side. So what those coefficients are telling us is that 1 mole of methane reacts with 2 moles of oxygen to make 1 mole of carbon dioxide and 2 moles of water. So let's say we've got 75 grams of methane. And let's calculate how much carbon dioxide and how much water we can make if that 75 grams reacts completely. So what's the theoretical yield? If everything goes perfectly, how many grams of each of the products can we make? So grams to moles to moles to grams. 75.0 grams of methane. 1 mole of methane is the same as 16.0 grams of methane. Get that from the periodic table. Grams methane divided by grams methane. Now we need our stoichiometric ratio to convert moles methane to moles carbon dioxide. It turns out it's 1 to 1. Seems like that's not a necessary step, but it's important to get in this habit of doing this process of grams to moles, moles to moles to grams. And from an algebraic standpoint, we will make sure our units come out right in the end. So mole CH4 divided by mole CH4 cancels. And now we can convert moles CO2 to grams CO2. And so from the periodic table, we can calculate that a mole of carbon dioxide is 44 grams. So mole CO2 divided by mole CO2, that'll give us grams CO2. So 75 divided by 16 times 1 divided by 1 times 44 gives me 206 grams of carbon dioxide. So that's my first theoretical yield for carbon dioxide. Let's do the same thing for water. So 75 grams of methane, 1 mole of methane is the same as 16 grams of methane. Grams methane divided by grams methane. Now my stoichiometric ratio, we want to convert moles of methane, we're going to have that in the denominator, to moles of water in the numerator. And that ratio is 2 moles of water to 1 mole of methane. Where do we get that ratio from? The coefficients to the balanced chemical equation. So moles methane divided by moles methane. I've got moles water that I want to convert to grams of water. moles water divided by moles water. That'll give me grams of water. 75 divided by 16 times 2 times 18 is 169 grams of water. As part of this problem, let's go ahead and calculate how much oxygen was consumed. How many grams of oxygen? Now we could use the law of conservation of matter as we did in some other videos, but we're on a roll here going grams to moles, moles to moles, and moles to grams. So let's do that again and then use the law of conservation of matter to check us this time. So 75 grams of methane. 1 mole of methane is the same as 16.0 grams of methane. Looking familiar, I hope. Grams methane divided by grams methane. Now moles methane to moles molecular oxygen, O2, that ratio is 2 to 1 for my coefficients to the balanced chemical equation. Moles methane divided by moles methane. And now I want to get from moles oxygen to grams O2. And that 1 mole of oxygen is 32.0 grams of oxygen. I got that from the periodic table. Moles O2 divided by moles O2, and that's going to give me grams O2. 75 divided by 16 times 2 times 32 gives me 300 with a decimal grams of O2. Trying to keep my significant figures correct throughout. And that decimal makes both of those zeros be significant. So according to the law of conservation of matter, the law of conservation of mass, however you want to say that, my grams of reactants has to equal my grams of product. So my reactants were methane, which was 75 grams, and oxygen, 300 grams. That's going to give me 375 grams of reactants. Should equal my grams of product. My products were 206 grams of carbon dioxide and 169 grams of water. So 206 plus 169 gives me 375 grams of products. They check out. Everything balanced out. Hooray.